Good morning, friends, parents, and students. My name is Pratibha. Welcome to Learning Center. So, today we are going to study decimals, that is for Maths Class 4. So, it will cover ICSE as well as CBSE syllabus. So, no need to worry. Okay. And please, it is a request. If you do like the videos, please do subscribe my channel. It will support me a lot. And please like it and share it with your friends and family members because it is going to be very, very useful for your study. Okay. So, let's get started. Decimals for class 4. So, today we will cover the topics that is the introduction to decimal, then decimal fractions. In this, we will do study about the decimal fractions as 100, 10, and 1000 as denominator. Then we will do study uh, place value of digit. In this, we will cover the whole part and decimal part. Then we'll do some exercise. In this exercise, we will also cover the conversion of number from decimal numbers to fraction and fraction to decimals. Okay. And the next topic is the addition and subtraction of decimal. And then we'll do some I will give you some worksheet. So in this worksheet, there will be some questions. So you can do it by yourself and share the answer in your comment section. Okay, so let's get started. The first topic is an introduction to decimal. So now, as we know, now you are in class 4, so you have gone for shopping with your parents lots of time. So you have seen the price tag of any item. It is like 5.87 rupees. Okay. So what does this means? 5 point, there is some point in between and then 87. What does that point mean? This point is a decimal that shows this is a decimal point, and after that the number that is 87 will not read it 87, it's 87. Because why we are reading 87, that we'll discuss later. Then these the the numbers that comes right side of the decimal point, they are called the decimal fractions, and left side of the decimal point, they are called the what they are called? They are called the whole numbers. So suppose we are going to the shopping and the price of some item is 5.99 rupees. So then this 5.99, again I'm telling you, this is a 5.99. So this 5 is a whole number. This dot shows the decimal, and this 99 is the decimal fractions or decimal number. So here is a difference between the fractional part or whole number. So these are called decimal fractions. Why we are talking about a decimal fraction? Because we'll do study in the class 4 as a fraction of 10, 100 and 1000 only. So that's why I'm calling you decimal fractions. So now in this, the number is expressed in a decimal. So what is a decimal? The decimal is expressed as a fraction in which numerator is not completely divisible by the denominator. Suppose if we are dividing 2 by 2, then what we'll get? We will get we will get 1, means this 2 is divided by the 2 wholly. There is no remainder left. Okay. But in decimal, there is a remainder. So that's why they are not called the complete number or whole number. They are the fractional part. That's why we are calling it fractional part. Okay. So these numbers are not fully divided with the denominator. So that's why we call it the fractional number. So in this class, as for example, we have a 9 by 10. So 9 by 10, we can also write it 0.9 or 0.9. And the another example is 5 by 100. So suppose it is a 5 by 100, how will write it? It is a 0.05. And then 4.8, this is also a decimal number, that is a 0.5. We'll do study in this decimals in the next class, I think. So We'll in this class only we studied a decimal fraction, and decimal fraction is a fraction in which denominator are 10, 100 and 1000 only. I hope this is very clear. What is a decimal, how we'll represent, what the point mean, what the whole number is, and what is a fractional part. So simply keep in mind the whole number is the left side part of from the decimal, and right side part of the decimal are the fractional part. Okay, so what are the decimal fractions? Okay, so let's quickly move to the whiteboard. So suppose in the whiteboard, suppose we have a piece of paper, we are dividing it into the 10 parts. Okay, then if we will cover this one part, then what we will write in fraction, you know, you studied the fraction in the previous classes. Okay, so what is this means, how you will define this part? This divide you will write is a 1 by 10, means we are covering only one part out of 10 parts. If suppose, so how we will write 1 by 10? It is equal to, see, whatever the number after 1, we will write the simple. Okay, this is the 0.1 or 0.1, both are same. How we will read it? We will read it 0.1 or 0.1. Okay, just a moment, because this is 0.1. Okay, so suppose for example we have let's say we have some other another picture. Suppose we have a circle and we divided it. So how many parts? 1, 2, 3, 4, 5, 6, 7, 8. Suppose this is a 9, a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. Suppose a circle is divided into 10 equal parts, and then if we will cover this one part, and this is the second part, and this third part. So how we'll write this in the fractions? This is 3 by 10. So now we will represent this as a decimal is 0.3 or 0.3. Both are same. So suppose if you want to know how we are writing this 0.3 or 0.3 as a fraction of 10, that is a 3 by 10, then simply there is a thumb rule to write it. Whatever the number, consider this point is called the 1. So simply we will write the number and then we will write 1 instead of point, and whatever the numbers after decimal, we will write these number of zeros. Okay, uh, I will tell you this technique afterwards. Okay, so right now you have to understand how we are representing decimal fractions as a denominator of 10. Denominator of 10 means what? We are representing it into the fraction as a part of 10. Okay, means how many number we are covering in the, if the partitions are 10. Okay, okay, so this is the decimal fractions as a denominator of 10. Now move to the slide. Okay, so how we are representing? Suppose I have a box in which there are 10 parts, and now the pink color, the purple color is covering the 4 part. So how we will define it? Now suppose there is one more example. If the same example we have seen in the writing board, the 10 parts we are covering one, how we will define as a fraction number. And then another example, there are 7 parts we are covering 7 out of 10. Okay, so we will represent in the decimals fraction, sorry, we will represent these pictures as a fraction. The first picture will be 4 by 10, the second picture will be 1 by 10, and the third picture will be 7 by 10. Okay, I hope there is clear that you have studied in the chapter fractional. Okay, fraction. So now we have to convert into decimal or decimal fraction. So how we'll write it? The first one is represented by, first one will, yes, it's zero point 0.4 or 0.4. Okay, the second one will be the zero point 0.1 and third one will be the zero point 0.7 or 0.7. So we will read the first one as a decimal 4 or zero point 0.4 or 0.4. The second one we will read it decimal 1, 0.1 or 0.1. The third one similarly, that will be the decimal 7.7 or 0.7. So in this way, we will represent the decimal fraction as a denominator of 10. Now we'll move to the next decimal representation, next representation of decimal fraction as a denominator of 100. Suppose that we have a paper in which we are dividing it into the 100 parts. Then if we are covering first part, so then in fractions, how we'll represent it? The first picture, that will be the 1 by 100. And the second picture, we are representing here as a 15 parts out of 100. So we will represent it 15 by 100. So the fractional number will be, for the first one is 1 by 100 and the for second one will be 15 by 100. Yes, it's correct. So how we will represent it by the in the decimal? So again, how you will represent? Switch to the whiteboard. Then now this 1 by 100 will be the same. See, there are two zeros. That one will be the point and this 20 will be the two numbers. If there are two digit number, then we'll represent whole as it is, but there is one digit, so after decimal there will be two digit. So you cannot simply write it 1. Okay, you have to represent it by 0.01. And similarly, suppose that the second example 15 by 100, so that will be the point for 1 and this 2 will be for the number, so that will be the 15. Okay, so 0.15 or 0.15 or that will be 0.01 or zero point 0.01. Now if I want to convert it into fractional, then this point is going to represent by 1 in a denominator. We will write the number as it is. 1 will be the point. And how many numbers are after decimal? That is a 2. So that we will write simply 20. Similarly for this, we will write the number and then this decimal is a point and then these are the two digit after the decimal, then we will write 20. Simply you have to write the zeros, the number of zeros is equals to the number of digits in in the decimal number after decimal. Okay, I hope it is a clear. So we'll go to the slide. Okay, so how we'll represent in the decimal number? It's 0.01 and 0.15. So I hope this is a clear. Now I have now next we will read the decimal fraction as a denominator of 1000. Suppose that we have a piece of paper, we just fold it into the 1000 time, and there is a one part we are covering. So we will represent it by 1 by 1000. And how we will represent as a decimal fractions? That is the 0.001. Similarly, if there is 154 part is covered, then that will be the 154 by the 1000. This is a fractional representation, fraction representation, and decimal will be 0.145 or 0.145. If suppose that, for example, there are 6 Yeah, I did one mistake. The number are different. So please forgive me. This is a 678 by 1,000. So that will be the 6.678. That is not 0.687. Okay, this is the mistake that I did. So how we'll write in the expanded form? So suppose I have an example. Let's quickly move to the uh, whiteboard to see the example. Suppose the number is 527 point. What was the number? Let me quickly check. 0.15. 0.15. Suppose that I have a number that I want to write in the expanded form. So simply, if suppose that you have a non-decimal number, suppose 20, not 201, then how you will represent it into the expanded form? That will be in the position of ones, in the position of tens, and in the position of 100. So you simply write 2 into 100 plus 0 into 10 plus 1. So that will be the 200 plus 0 plus 1. That will be the 201. So it's the same way we will represent the decimal numbers. So how we are going to represent the whole number, you know. So simply it will be the 4 into 100 plus 5 into 10 and plus 2 into 1 or 2. Or simply we have the point. Okay. I'm not able to make the point. Okay. This is a point. Okay. So suppose now I want to represent this 0.15 into decimal. As we know, for the first position of decimal, it is represented by the denominator 10. So we will write it. We are not going to make point here. Okay, we'll write it 1 by 10. And now for this digit or 5, we'll write it 5 by 100 because this is in the second position. The number of position is equal to the number of 0 in the denominator. It is a second position, so there will be 2 0. And in the first position, there will be 1 0. So how you will write it? Simply 400 plus 50 plus 2 plus 0.1 plus 0.05. If we are going to add all these numbers, we are going to get the given number. So this is called the expanded form. I hope this is clear. Let's quickly see the one more example. Okay. So suppose I have a number 205.34. So you will simply write 2 into 100 plus 0 into 10 plus 5 into 1 plus 3 by 10 or 3 multiplication by 1 by 10 and 4 divided by 100. That will be the 200 plus 0 plus 5 plus 0.3 plus 0.04. So this is the expanded form. Uh, 0, 0. Okay, so I hope it is clear. Now move to the next slide. So similarly, we had seen in the whiteboard. So it is a simply 4 into 100 plus 5 into 10 plus 2 into 1 plus 1 by 10 and plus 5 by 100. That will be equals to 400 plus 50 plus 2 plus 0.1 plus 0.05. So let's move to the next slide, that is a place value in the decimal. As we seen that place value in the normal number, that is a whole number, we have the place value in decimal as well. So the decimal place value starting from the right side from the decimal point. Suppose that we have a table, we are representing the number here, and there is a decimal point, that is the white point. So from the decimal to the left side, that will be the whole number. So the first place value will be the 1, that is ones, then tens, the second number, then third number will be the thousand, and the fourth number will be the the third number will be the hundred, and fourth number will be the thousand. Similarly, we have a place value after decimals towards right side. So if we are moving one step towards right, the decimal value will be tenths. See, there is a tens and tenths. So there is a difference. Tenths means tenths number, one in a tenth. Okay. The second position will be the hundreds. Means out of 100, how many? Okay. Then the next will be the thousands. Not thousand, is a thousands. So there is a difference between the decimal place value and the whole number place value. So I hope this is a clear. Let's quickly move to the next slide for the example of place value. So suppose we have a number that is a 9,756.342. So how we will represent it into the decimal values? So simply we will write the number in the positions and then we will see. So for the whole part, the simple 9 in the position of 1000. So this is a 1000 positions. Place value will be the 1000. Then the 7 in the position of 100. The place value of 7 is 700. The place value of 5 is tens, that is a 50. And 6 place value will be the 6. Then after that decimal, the place value will be changed. So the place value of 3 in the decimal part will be the 3 by 10. Then the place value of 4 is 4 by 100. And it is below than 1. It's less than 1. Okay. And the place value of 2 will be the 2 by 1000. So let's quickly see the same example in the whiteboard. Okay. So as we know, the place value will be the same. This is a place value of 9. This will be the place value of 7. This will be the place value of 5. And this will be the place value of 6. Now, what will be the place value of 3 here? That will be the 3 by 10. Okay. And the place value of 4 will be the 4 by 100. And the place value of 2 will be the 2 by 1000. So these are the place value. That is a 100,000 place value. This is in the place value of 1000. This is in the place value of 100. This is in the place value of 10. This is the place value of ones. HTO pattern, you know. Okay. Now about the point numbers after decimal, the place value of 3 will be the tenths. The place value of 4 will be the hundreds. That is a 4 by 100. And the place value of 2 will be the 2 by thousands. That is a thousands. Okay. So I hope this is a clear. So how we will read the number? We will read the number 9,756.342. We are not reading 342. It's 3, 4 and 2. So now it is a clear why we are calling it 342, not 342, because this is a fractional part. It's not a complete number. We always call the complete number by its position, but we cannot call the decimal fractional number by the positions. Okay. So let's do some exercise. Suppose we have a first problem. This is a write as a common fractions. Okay. So let's say we have a point 0.102. So how we'll write in the common fractions? Suppose we have example point 1, 0 and 2. So we have to write in the fractional number. So we'll simply write the number first. This is the first thumb rule. We have to write the number. Then in the place of decimal, we'll put 1 in the denominator, and whatever the numbers after decimal, we will write that number of 0. How many numbers are there? There are 3 numbers, 1, 0 and 3. So we will simply write 3, 0. So this is a conversion from decimal to fraction number. Fraction number. Okay, so let's quickly move to the slide and see the next example. Okay, this is the same 102 by 1000. So convert into the fraction number into decimal. Suppose we have a 48.100, 48 by 100. So how we will do this problem? So simply we will write the number that will be the 48 divided by 100. So simply whatever the number in the denominator 0, how many zeros are there, that will be represented in the digits, and 1 will be the point. So we'll simply write 4 by 8. How many zeros are there? 2. So we will write the point or decimal after letting the 2 digits. We have to leave 2 digits after that. This is the first digit, this is the second digit, and we have to put point after before 2 digits. So let's see one more example. Sorry, this is example number 3. The third example. Okay, suppose we have a number. This is a 51 by 10. So how we will represent it into the decimal? So we'll simply write the number 51 here. Then how many zero is there? There is only single zero. So we will simply left this single digit from the right side and put decimal after that. Suppose example, one more example is there. Suppose we have a 63 divided by 630 divided by 10. So let's say it's 100. Okay. Don't consider as a, let's say it is a 63 only. Okay, let's say the example, this is a 63 divided by 100. Now we have to write the number 631 divided by 100, and how you have to convert this number into the decimal numbers. So simply we will, the first step is simple. We have to write the number. Then the second step, we have to count how many zeros are there in the denominator. So there are 2 zeros. So from the right side of the number, we will leave the number of zeros, the number of digits that is equals to the number of zero present in the denominator. So there are two zero present in the denominator. So we'll left these 2, 3 and 1, and then we'll put decimal before 3. So that will be the 6.31. So I hope this is a clear. So let's quickly move to the slides to see the next problem. Suppose we have one more, that is a convert decimal into fraction, that is a 0.07. So simply what we will do, we will write the number and we will put the 1 instead of point in the denominator, and the number of digits after decimal, that will be the number of 0 in the denominator. So in this example, there are two digits are there after the decimal, so that will be the 20, that will be the 7 by 100. I hope it is very, very clear to you. So let's move to the next slide. Next problem. So write the expanded form of 0.35. So how we will write the expanded form of this? So simply see in the whiteboard, there is a 0.35. So simply it is in the position of tenths. So that will be the 1 by 10th. That will be the 3 multiplied by, and plus this is in the position of hundreds. So plus 5 by 100, or 5 into 1 by 100, that will be the 0.3 and 0.3 and 0.05. So that will be the expanded form. Okay, so let's move to the next example. So the next example is 0.406. So how you will do that? So simply 0.406 will be the 4 by 10 plus 0 by 100, because it is in the position of 100. This is in the position of tens, and then 6 by thousands. So simply we'll write it 0.4 plus 0.00 plus 0.006. This will be the expanded form of 0.406. So I hope it is clear, because we know the place value. Okay, so let's quickly move to the slide. The next example is the convert into the like decimal. Okay, in the previous fraction chapter, we study about the like fractions, unlike fraction, okay, or mixed fractions. So in this, there is a like decimal as well. So suppose you have three numbers, 2.35, 331.5, and 12.72. Now we have to convert it into the like decimals. So like decimals means what? The number of digits will be the same in each numbers. Okay, suppose 2.35. How many digits are there after decimal? 2 digits. 31.5. How many digits are there? This is a single digit, 1.5. Okay. And in the 12.72, there will be the there is 2 digits. So now we have to convert it into the like decimals. So in the like decimal, the number of digits after decimal will be same. So let's quickly move to the whiteboard. So suppose we have this number. Now we have to convert it into the like digit. So simply we have to make over the digits after the decimal. That will be the same. So we will simply write 2.35, 31.50. Now to make the digit like, we have to put 0 after the number, not before the number. Before the number, the value is changed, and after the number there is no change in value. So this 31.5 is same equals to 31.50. This is a simple rule. After this 0 after the digit, there is no means. Similarly, for the whole number, after 0 the meaning is changed, and before 0 there is no change in the meaning. So in the decimal, this is the only difference. Baki, otherwise it's almost same. Okay, let's move to the next slide. Okay, now addition and subtraction of decimal numbers. As we know the addition and subtraction of whole numbers or normal numbers, real numbers. Similarly, we can do the addition and subtraction of decimal as well. The only thing you need to remember is that decimal should be at the same place for all the numbers. So let's say we have to add 7.25 and 6.08. Now we have to add. So let's quickly move to the whiteboard. Now we will simply write 7.25. Below the 7.25, we have to write 6.08. So point below the point, and after point, you have to write the number as shown in as I am writing. Okay. And then simply we have to add the numbers. So 5 plus 8 is 13. 3 is there, 1 carry, then 3 point as it is, and then 7 plus 6 is 13. So answer will be 13.35. So we have to simply write the numbers and then you have to write the answers. Next example, add 3.55, 3.005, 3.5 and 3.05. So we simply write the numbers. The first number will be this, second number will be, third number and fourth number with addition sign. Now we have to add. Now we are making it like fractions. Why we are making like fractions? To not get confused. Hmm? Okay, so simply we'll add. We have to start from the rightmost digit. So 5 plus 0 is 5. 5 plus 5 is 10. Carry 1. 5 plus 5 is again 10. 10 and 10 plus 1 is 11. That will be the 1. And then 3 plus 3 plus 3 4 times and plus 1. So that will be the 13. So this is a clear addition problem of the decimal digit. So the addition will be the same. Only you need to remember there should be decimal of all the numbers together. Means it should be below numbers. If you are writing something like, let's quickly move to the whiteboard to see what to avoid. Okay, suppose we have to writing 3.05, then 3.55 and 5, then 3.005. So these are all alike, so that you don't need to do. You have to write the decimal below the decimal, like 3.05, so 3.555 and 3.005. So all the decimal are at the same place. It should be at the same place. It can be changed, no problem. It can be changed, no problem. Decimal should be at the same line. Okay, this is the simple thumb rule you need to follow. Okay, let's move to the slide. So we have seen the example of addition. Now the example of subtraction as well. So let's say we have to subtract 6.056 from 8.403. So how we'll do that? We simply go to the whiteboard. We have to subtract 6.056 from 8.403. So simply thumb rule, the bigger number will be at the first place. So 8.403 and then subtraction sign 6. The decimal should be at the same place, 056. Now, as we know how to take borrow, we'll do the simple as we did in the previous classes. Okay, so 3 cannot be minus from 6. So we'll take the borrow from 4. That will be the 3. Then this will be the 10. Now the 3 is going to be take borrow from 10. It will be become 13. So 13 minus 6 will be the 7. And then 9 minus 5 will be the 4. 3 minus 0 will be the 3. Now subtract 8 from 6. That will be the 2. And decimal should be there. So answer will be 2.345. So it will be the Okay, I think I did some mistake in the PPT. So uh, let's move to the next topic, next example. Okay, so the example is subtract 0.909 from 0.997. So simply we'll go to the whiteboard. 0.997 and 0.906. Simply we have to minus. Okay, so 7 minus 6 will be the 1, 9 minus 0 will be the 9, and 9 minus 9 is 0, and decimal is decimal here. So answer will be the 0.091. Okay. I did one mistake in the writing the number. That is not 6. This is the 9. Okay. So I am making it 9. Okay. Now we'll correct it. 7 cannot be minus from 9. We'll take the borrow. So it will become 17 minus 9. That will be the 8. And 8 minus 0, 8 minus 0 is the 8. So answer will be the 0.088. I did mistake in writing the number. Otherwise, the method is same. Okay. So let's quickly move to the slide. So this is a worksheet. These are the some problem for you. So please take a screenshot or write down the questions so you can do it from yourself, and do let me know the answer in the comment section for each questions. So I'm waiting for your answers, and thank you for watching this video. If you find this video is useful to you, then please hit the like button and subscribe this channel for more videos. So that is a support from your side. So thank you for watching the video. Yeah.